Would you believe that you are actually smarter than your calculator? I wanted to show you a few ways you can do that. And you can do that by using the properties of logarithms. So here is a question. X raised, or what is 5 raised to the 2020th? That one, you try typing into a calculator, this is what you're going to see. 5 to the 2020th, error, overflow. It's too big for it to handle. And so how can we get an answer? Because there is an answer, right? I mean, 5 to the second has an answer. It's 25. 5 to the 20th has an answer. It's a little bigger. I don't know that one, but it has an answer. Certainly this has an answer. It shouldn't be undefined or anything like that. To do that, what we'll do is use logarithms. And so what we're going to do is take this and take the log of both sides. If you take the log of both sides, now log of 5 to the 2020th, can't type that into your calculator. This hasn't really helped us much, but we can use the exponent property to rewrite this as something that we can calculate. The 2020 as an exponent inside of a logarithm can be pulled out in front as a multiplier. And this now is something that we can type into our calculator. If we type 2020 times log of 5, we'll get this 1,411.919 number. So log of x is equal to that. Now to undo log of x, what we need to do is to raise both sides on top of the 10th power. And so 10 to the log of x undoes itself and gives us x. This number, I'm going to split it up in a weird way. I'm going to write the decimal part and then plus 1,411. But I'm going to raise this side on top of base 10. And so 10 to this can get calculated as 10 to the 0.919 times 10 to the 1,411. And this part, 10 to the 0.919, is something that you can type into a calculator. If you do that, you get this 8.29 number. It's this which was causing the problem for your calculator. 10 to the 1,411 is such a huge number that it causes an overflow. If I remember right, the calculators, CI83s and 84s, they max out at a Google, that is 10 to the 100th. So if you have any numbers that are bigger than 10 to the 100th, it's going to give you that overflow error. So anyhow, that is kind of a neat way of getting around the limitations on your calculator that require the use of log properties. Here is a similar sort of question. If you were to try to type 400 factorial into your calculator, you can't. It gives you another one of those overflow errors. And how can we find this if we don't, if we can't use a calculator? Well, let's try to figure out what 400 factorial means. So 400 factorial means 400 times 399 times 398 and so forth. Don't think that you're going to get around this problem by just typing this out, 400 times 399 times 398. Yes, you can do that for a while, but eventually you're going to get a number that's too big for your calculator to handle. Not to mention that's going to take forever to type up. But we can take a logarithm of both sides. And so if we take the logarithm, this is one giant multiplication. And the log properties say that one giant multiplication can get split up as a bunch of logs added. And so we've got log of 400 plus log of 399 plus log of 398 plus log of 397. And this is something you could actually type into your calculator, and it will actually work. It would take you forever to type it in, but log of 400 is just a number. It's like 2 point something. Here's another 2 point something sort of number, and you start adding all these 2 point somethings in there. It's not ridiculously big. It is doable. But I'm not going to waste my afternoon typing all of these things into my calculator and find out that I mistyped something along the way or something like that. And so I'm going to summarize these using summation. And so they all are log of something. right? Log of something plus log of something plus log of something. So the formula here is log of something. I just chose the letter A, and the numbers that I'm putting in here are all the numbers from 1 to 400. And so this is something that I could type into my calculator pretty easily. To do that, you've got to use the sum of sequence command. So the sequence is log of A, and I'm letting A range from 1 to 400. And then I take the sum of that. If you type that into your calculator, you get this 868 number. And so that's what log of x is equal to. And like we did in the last problem, to figure out what x is equal to, we're going to split this up into its decimal form and its integer part. It's the integer part, 868, which is why this is so big. This is a number that's got 869 digits in it. Yeah, your calculator can't display that. But if we split it up like that, we can take 10 to each of these parts. And 10 to the 0.806 is something you can type into your calculator. And you'll get this 6.4 number. And it's this 10 to the 868 part that you'll just have to leave off. So anyhow, that's kind of cool that we can outsmart our calculators by using log properties. I hope that helps. Let me know if you have any questions, and I'll catch you in the next video.